Hi, my name is Erica Gamble, and I'm a microbiology student here at Wilkins University. And this is my Physics 101 final project. So for this project, I decided to calculate the gravitational acceleration in Ankara, Türkiye using a pendulum. And I used the US customary system and then converted it to the metric system in order to see if there's some error that comes between converting units, because we so often do that in the US, but coming here, I see that it's not as common of a thing to do. The equation to calculate gravity is derived from Newton's second law, force equals mass times acceleration, because a simple pendulum's motion is controlled by gravity. So the restoring force that pulls the pendulum back and forth and creates more acceleration is the gravity pulling the bob towards the lowest point. And with small angles, this back and forth motion becomes nearly perfect simple harmonic motion, which leads us to the equation gravity equals 4 pi squared times pendulum length over period of pendulum. So to experimentally calculate gravity, I used this pendulum setup and I used a piece of fishing line at different increments of lengths that were all measured in inches. Fishing line that was non-flexible so that the force that was creating the pendulum swing had minimum resistance, smooth metal bead for the same reason. And the starting angle was a 10-degree angle for each time to minimize any other forces that could be contributing to acceleration. So once the pendulum was set up, a 10-degree displacement angle was used to start the pendulum, and 5 oscillations were counted. One oscillation is when the pendulum returns to the same point, and then that oscillation time is divided by 5 to get the time for one period, so one back and forth motion. I'll tell you when. Start. 1, 2, 3, 4, 5, stop. So from the raw data, we can see that as the string length increased, so did the average period of the oscillations. So from the period that was derived from the raw data, we were then able to calculate the gravity, first in inches per second squared and then in meters per second squared. And the values were pretty similar to the 9.81 value that we used in physics class. So as the string length increased, the oscillation time also increased exponentially, which tracks with the equation that we saw before. And to linearize the data, the period squared was graphed against the string length, which gave us this linear equation. When comparing the experimentally derived linear relationship between the string length and the average period squared with the expected period that is derived from the known g value with the known string length, we see that the values are very similar. However, there's a much bigger percent error, percent difference with the smaller string lengths in the pendulum. Whereas the longer string length, the 36-inch pendulum, had very little error. It was negative 0.1% difference between the expected g value and the derived g value. This is